Let us start our today's lecture on power plant engineering. We are starting a new chapter known as named as steam power plant. Now, what is steam power plant? What we have discussed so far, the different requirement of load, different application of how to do the control the economics of the power plant itself, and briefly we have decided in the first chapter all the required elements which is required to run a power plant itself. But now we are going to the details of individual type of power plant itself. A steam power plant, a steam generator, is defined as a complex integration of furnace. What is steam generator is not a single type of equipment, a single type of machineries, or but it is the integration, means a summation or addition, a complex setup of, say, furnace where we burn the fuels and to create the heat itself. And what are the fuels used? We have discussed in the introductory factor that mostly we are using in power plant is the still today is the coal itself. There are power plants for nuclear power plants where we use enriched uranium for the fuel itself. For hydraulic power plant, we use water to replace the fuel, and mostly these are the three different types of power plants. Sometimes we use the petroleum oils of different categories for the generation of furnace itself, especially in steam in the marine power plant itself. Next, we go for the superheaters. The fuel is being burned in the oxygen of the atmosphere, with oxygen of air itself. But if the air is used as a in a cool temperature or a room temperature, then your more fuel is required to burn to make the to generate the heat for boiling of water itself. So we are using a function known as supervisor or reheater itself, which heated the incoming air up to the almost near to the boiling point, so that not to the boiling point of water, so that the fuel can burn very quickly and easily without, and can make the required temperature as fast as possible itself. Next is the boiler or superheater or evaporator. Next, what we produce here is the evaporation process. Means we evaporate liquid water into the steam. So boiler is sometimes defined as superheater, evaporator, or only boiler itself. Economizer and air preheater. Now, what we do is economizer is also a preheater. One type of preheater is used where is named economizer, means it uses the previous heat of the burn of fuel to heat the incoming air, and air preheater is also work more or less in the same fashion. There are various exercises like pulverizers. What is that? You receives the coal particles or coal in different size of particles, which is extracted from the different mines, but those particles cannot be used directly because the fuel well requires a specific size. The fuel furnace requires a specific size of the inputs of the coals, so you have to pulverize or broke it into specific particular size, which I have discussed in the earlier panel, and those operations being done in the pulverizer itself. Next, the burners. Sometimes how will you burn the fuel? How will you initiate the burning of the fuel? We require burners like which may use oil to start the burning of the fuels, which maybe creates flame, where all these fuels, all these coal particles or coal substitutes starts burning itself. Light is lighted and starts burning itself. The fans means there should be a continuous flow of heated air throughout the system, and only if there is no fan like this, the air which is being heated in the air preheater and economizer may not make the circulate through the uh, fuel fuel tank. I mean the furnace itself. So we need the fan to be say, fixed and run in specific process. Stokers, where stokers is the wreckage of all the all the dustes or all the ashes created different type of ashes created different size and different categories of ashes, and sometimes they are clapped together, make a assemble ashes together, because sometimes ashes are sticky in nature, and you have to break it into again to the specific size, and so that you can correct it out quickly. There is dust collector. Sometimes this ash is totally converted into totally is an ash content, and it is like a dust, and you have to collect the dust in different ways, and you have to participate the dust so that you can should not go to the atmosphere and pollute the atmosphere to that extent. And ash total, there is a ash handling plant and chimney or stack. Through the ash handling plant, all the stokers, dust collectors, and precipitors are operating, and all the ashes are collected and kept in a proper way in the proper area outside the furnace, where it is the ash known as ash ponds or like this, where you have to collect the ash, and afterwards you can use it in some other process, or you can send it back to for send it back to fill up to make the fill up of certain cavities or something like that, or certain filling of the filling of the lands or so. But what we have to do with this broken ash of the plant is really a problem for the initial and the running of the steam power plant itself. Next is the chimney or stack. The height of the chimney and the size and shape of the chimney is an important factor in order to send this particular, in order to send the fumes to a considerable distance away from the locality of the furnace, but it should not, it should be mixed properly in the air and go out by the air wind pressure. Otherwise, all the surroundings atmosphere will be total dirty, or total dirty, and his oxygen will be wasted. But there are specific process exists at this moment that very little amount of burning is smoke is being released or stacked through the release from the stack itself. That boiler is that part of the steam, the part of the steam generator where the phase change, or that is boiling, converter of water to the boiling itself occurs, and occurs from liquid motors, liquid water to the vapor. So what we do essentially, the boiler, we convert the liquid water into vapor in the form of a vapor or steam, and essentially we do the same at constant pressure and temperature. However, the term boiler is identical, traditionally used to call the whole steam turbine unit, steam generation unit. So boiler clearly indicates the total steam generation unit, which contains so many parts, but we generally refer to as the boiler for a steam generator itself. Now, basic type of steam generators. Say boilers are classified as utility steam generator and industrial steam generator and marine steam generator. Boilers are classified according to this use into different type of steam generator itself. One is defined as industrial utility, then is industrial, and this marine steam generator. Now, what are the utility steam generator? Utility steam generator means they're adding a term. Utility means it has the steam has other applications, other requirement than generating power itself. They are used in the electrical power generated general plant, of course. Depends whether the pressure of steam is below or above the critical temperature. They are above the critical temperature. They can be either subcritical or supercritical. What is critical temperature? You know, for if you go through that um, TS diagram of if you go through the psychometric chart or TS diagram of a steam, you'll find at a temperature where they exist, where the total amount of liquid water is converted totally to steam as per a given pressure, or before, if the pressure and the temperature is less than that, oil is being converted, all right, but there is a mixture of water particles and the steam particles. But if we Boil this temperature over, boil your water over a critical temperature, there will be no chance of creating any liquid droplets, liquid water droplets, but full water is converted to the steam itself. So, so either you have to know the critical temperature as per your the pressure you are creating inside the boiler itself. The the supercritical boilers. So we are having subcritical and supercritical boiler. Whether the boiler is being at being operated between subcritical range or supercritical range. Now, the subcritical boilers are water tube drum type and usually operate at between 300, 130 to 800 bars steam pressure. The supercritical generators are drumless. There is no drum for collecting because it does not require to collect the water particles, water steam mixture, and because it's totally steam is totally available in terms of in terms of the moisture itself. Not any not any particles of water is present there. Now, uh, the operates 240 bar pressure. Generally, the drumless one screw type supercritical boiler. Drumless one is there is no drum. One screw means totally in a one single time it is converted to the water is converted to the boiler and operated at 240 bars pressure or higher. Also, we for supercritical boiler which we use operates at 240 bars pressure or so. Majority of boilers are there generally 170 to 180 type 80 bar pressure, while the tube drum variety, which produces superheated drum and but water tube drum variety and which produces superheated steam at about 540-600 degrees centigrade with one or two stages of heating. Sometimes first you heated the water to make a mixture of under the critical temperature and make a mixture of steam and water. Then you send it again by reheating to make the boiler at a temperature of 700 to 800, 800, 700, 172 and which operates the superheated heat at 540 to 600 degrees centigrade with one or two stage heating. The steam capacity is ranging from 100 to 1300 kg per second. Means how much steam we are generating. Its capacity is 120 to 1300 means almost 1.3 tons capacity steam is being produced per second. The power plant energy generally varies from 125 to 1200 megawatt because more or less 12 to 1400 megawatt is the maximum power can be generated by steam turbine, steam power plant. If you need more power, so that you have to produce different type of boiler unit, a number of two or three or four different boiler units, which is called super power, thermal power station. Now, here superheated steam is about heated to 540 degrees centigrade, 200 to 600 degrees, one or two stage heating. So, as the temperature of boiling water is 100 degrees centigrade, it is being heated, converted to the moisture before the boiler is formed, water is formed. It is and needs to be heated up to 540 to 600 degrees centigrade with one or two stages heating. The steam capacity is ranging from 130, steam capacity ranging from 120 to 1300 kg per second, whereas power plant output is generally 125 to 300 megawatt. Sulfurized coal is mainly used, means it is coated, broken up to a particular size, and then it is being used in the for burning in the fuel in the furnace itself. Another type is required for the industrial generator. Now, those boilers used to process industries, used as process industries like say sugar, power, pepper, jute, etc. Process industry means which process is a cyclic process and it is not starting or stopping, but it is continuing for a longer time and for a long time. And here a lot of different applications are available of the steam itself. So up to a certain degree temperature, say around 125 or 130 or so, the steam is generated for considerable amount, and This steam can be used like industries in sugar, paper, jute, etc. They are required certain amount of moist air, moist water in terms of steam, like stupor, paper, and jute itself. That's why all these industrial steam generators are being produced on the place of this requirement. Means where it is placed in the sugar coal, it placed in the sugarcane factories like this. There are industries like there are other applications of this industrial furnaces. Industries like hospital, commercial industries, and rebuilt residential building here will find the application of steam itself. For the hospital, the steam input is required is produced to clear the dust, especially in the garments used in the steam. It should be fast and free from sort of moisture itself. Now, same is case with sugar, jute, paper, etc. And industries like industries require commercial and residential building. There is application for this thing, the commercial residential building before really complex. As there are smaller in size and generate at power at ranges 5 to 105 degrees centigrade with and majority of the boilers at ranges uh, the hospital, commercial, residential buildings are also have use of the supermetal copper because in the hospitals all the dirty clothes which is replaceable, which is not replaceable can be washed by send it is keep it inside the volume of the steam so that every wastage is cleared. And generally industrial steam boilers are smaller capacity, generally 5 to 105 bars and steam capacity around 125 kg per second, not more than that. They don't produce superheated steam. They supply wet or saturated water and sometimes also supplies hot water even to the person where it is being used. Now, next comes they don't produce superheated boiler, steam is not required, supply wet or saturated steam and sometimes only hot water itself. Let us go for the superheated marine steam boiler or boilers are used only by used only in marine ships. Their boilers are generators are used only in marine ships. Next is the here the marine steam are used only in the marine ships. They are where the source of power cannot be available for the external any from the land or anywhere else, any other source is there available. Sometimes today they are using the solar light, but mostly they are using the boiler-based boiler, which is being boiled where fuel is the liquid petroleum or at least different type of oil, good enough to create high octane temperature for minimum amount of use, and water is used all right, but the force of the flame is being heated according to the law itself, according by means of the liquid oil itself. In earlier ways, the streamliner carries the coal himself to generate the power through the boiler itself. But nowadays, to avoid pollution and due to avoid a rapidly available oil in almost everywhere in the world, the ships are concerned are using the oil, and slowly the genetic process by the boiler is being established, being felt. Generally, they are oil fire. They produce super streams about 65 and 75 bars pressure and 550 degrees centigrade. So superheated steam is around 500 degrees centigrade is the production heat of the superheater itself. Boilers can also be classified according to the relative flow of production. How? The combustion or flue gas and water. There are two different ways. There is a fire active boilers. Now, how? What is the meaning of relative flow of production and combustion of flue gas, and how the water is being flowed, and how the flue gases is being generating heat to heat up the water itself. There are two different types. One is fire tube boilers, where hot gases are passing through the tube surrounded by water, and by this temperature rise, the whole water is raised by certain amount of above the equal to the superheated temperature like 500 degrees centigrade or so. Or sometimes water tube boiler, where water from a drum flows through the tube and hot flue gases flow over them. In fire tube gas, hot gases flow through the tube and water is in a shell, and water tube boilers, water is pumped from a drum from which through the big and hot leverages power there. Hot level power from it. Water with drum flies through the tube and hot flue gases fight over the drum itself. What is the fire tube boilers? Nowadays, a fire tube boilers has limited application in railway locomotives and river launches. Almost these fire tube boilers are abolished. Means actual means the heated flue gases flows through the tube and surrounding the water is doing the surroundings, so that the heat is transferred to the water and water converted to steam itself. But nowadays, fire tube boilers are limited application in railway locomotives and never launches the uh, in fire tube. Nowadays, fire tube boilers have limited application in railway locomotives and river launches. But in industry, they are now used to produce saturated steam at upper limit of 18.18 bars and 1.6 kg per second capacity and per second steaming capacity. So mostly now this type of boilers are used in in industries where they require saturated steam at upper limit or at a pressure of 18 bars and 2 kg per second capacity is required, also the steaming capacity. For small requirement, they are mostly used for limited requirement. They are mostly used for limited requirement. They have certain inherent advantages like low fast cost. Initially, you have to spend less money to make this type of fire tube boilers, and reliability in operation. Is operation is quite reliable and requires installed unskilled laborers, and those less draft is required and quick response to local changes, load changes. So fire sales as the most important plus point is it can quickly change process to load requirement, because you can quickly apply more fuel like coal, and with pulverizing, after pulverizing it is sent directly to the flue gases itself. And the temp is vapor requirement or power requirement will go up and immediately and goes to the various section of the power plant itself. A fire tube boiler is called so because the product of combustion passes through the tubes or flues. So product of combustion means certain gases, certain smokes, air all carrying the heat of the fuel which is generated through it and passing through the fluid tubes or flexes which are surrounded by water itself. They can either externally fired or locomotive, for example, locomotive boilers itself. Industrial fire, that is scratch marine boilers, package beads. Figure with the next page what I will show, it is it is the a typical externally fired fire tube boiler in which furnace is outside boiler shell. The coal is supplied annually in shovels to the grid by open fire door itself. But I'm showing you that first. The typical fire tube boiler is what we have here in furnaces outside the boiler shell. Where is the furnace itself? This is the smoke box. This is the exhaust gas chimney. Butterfly valve is there. The valve is required. If necessary, you can stop the exhaust fan go out and draft of the chimney. We have to create draft so that it can by automatically goes up out. The steam house is stop valve here is the outlet of steam, and ramshackle safety valve. Steam space it is going on inside the steam itself, where fire tube boiler means all the gases are starting from the furnace itself. After burning the fuel, say coal, is going up and goes there through the fire tube and goes out through the burner itself. And full fire tubes are being surrounded by the water itself. Now, there are some safety valves here, some steam space here, and 85% magnesium is produced here. And water tube indicator, there is a level of water here. The flexible plug, if necessary, you can open the plug to release the water, reduce the heater slug in here, and the firebox where the safety arrangement for additional heating or some burning on coal can be supported by providing the foams and other things. These are the coals and coal bed and a blow down valve. So all these stacks are created, all these assets created is then legally here the air is coming in, that air heater or economizer maybe in from the process of air, it is coming here and mixing the water, and there the grate where the water is going out, and Broker's valve is there, breakdown valve is there to burn the water itself. Now what we have is, just let us go back to the original one. Now, we got in the figure said externally fired fire tube boiler in which furnace is outside boiler shell. So, boiler shell is required, furnace is outside boiler shell, furnace is burning the fuel separately, and they are only supplying the liquid hot air through the tubes which is going through the inside the boiler shell, and it carries the water surrounding it. The coal supplied in manually here, generally the coal is supplied manually by shovels to the grates by opening the floor fire door, or sometimes it can be fired by means of the conveyors and which is running at a specific fuel heat and supplying the coal to the furnace itself. Next, hot product of combustion passes through the tube which are immersed in shell containing water. And what is this? Very clear. All air combustion is flowing through the tubes which is immersed in shell containing water. It is totally housed and immersed in the water while surrounding it, and inside it hot flue gases are flowing and heating the water itself. Now, a fusible plug made by low melting point lead-based low melting point lead-based alloys is installed in the roof of the crown in the furnace. If the water leveler in the shell falls below a certain level, the fusible plug melts due to overheating and water flows down through the hole formed and puts on the fire itself. So we should be very careful about maintaining the level of water inside the boiler drum, and there is a melting point fusible plug. Fusible means it which can be burned or made by low melting point with lead based oil is installed in the roof of the furnace. If the water leveler is shell below, actually the water still present inside the shell got excessively heated and got heated and create this fusible plug melts down. And so from there, water pours down to the hole formed and put into the fire itself, so that the more cold water is sent through this system, which is being heated by the water fire tubes inside it, and thus the additional heat is being used to heat the water itself. A spring level safety valve is also used to keep the boiler pressure within the safety limit. Spring is set in such a value that its upward thrust of steam should be equal to the downward outer shard of thrust of steam should be equal to the downward, which is 2. 3, is the downward thrust of the spring itself. So the high pressure large diameter also provided thick shells and thicker shells. Now, the spring is set. We have a spring level safety valve where we use springs. The pressure of the spring is used to keep the boiler pressure within the capacity limit. Boiler pressure itself has a maximum capacity without it cannot exceed that capacity, so that it can break and burst. So within the boiler pressure limit, the spring is set in such a way that upward thrust of spring should be equal to the downward thrust of the spring itself. So it is just balanced by the downward thrust of the spring and the upward thrust of the water, also water steam water mixture is pushes this valve. When the the steam pressure inside exceeds the upward thrust of the spring, then valve is open and additional some amount of vapor will release to the atmosphere, so that the differential level goes down and steam will be released with a hissing sound itself. Now, steam pressure inside the cell will go down till the lead is forced back on the seat, and the hot flue gases goes through the tube, transfers the heat form to the water wall. 1 second. Steam pressure inside the cell will go down till the spring lid goes back on its seat, till the lid goes back on the seat. The hot flue gases going through the tube transform the heat from gas to water wall itself. Along the length, the gas is cooled and water is being heated, and there is a nuclear boiling surrounding the tube, and the steam is thus formed. The steam is taken out by the required rate by opening the main stop valve itself. If we want the steam to our product, we can take it out by using, there is a stop valve is there. We take out the steam and use it to our other machineries. The steel always insulated all around by the asbestos and 85% magnesia to reduce the heat loss almost to negligible due to surrounding itself. Uh, Airflow from below the gate is regulated by operating dampers according to the requirement of combustion. An elliptical manhole is being provided for main for a main to go into to cleaning and repair as the need arises. So what is doing here? Prothom kata, this shell, boiler shell, which is carrying water and which is housing the flue gas inside, should be totally heat proof. It is totally covered by asbestos itself, and 85% magnesium asbestos, which contain 85% magnesia, to reduce the heat loss so that it is absorbing heat and doesn't let the heat go out to the surrounding atmosphere itself. The airflow from below the gate is regulated by operating dampers. They are the operating dampers according to the requirement of combustion. An elliptical manhole is provided as a main to go inside cleaning and repair as the need arises. So we should have a manhole here where which is required to go inside the boiler itself after clearing out all their burning water or so that he can go through a different problem coming into the boiler itself. Now, a oil-fired pressurized is shown in the sketch itself. It is an internally fired it is an internally fired, just one second, let me open. This is the oil fired package furnace. What you see here is the water drum. This is the water steam spacer and water drum itself, and the flue gases are flowing through these tubes inside the water jet itself, and this also a corrugated flue will go outside. It is coming here, through it is going up, and coming here it is going through this side like this. So the heated flue gases coming here, going in, coming through the thin, and then through these three tubes inside, then goes out through the steam outside, thus hitting the surroundings of the tube to that extent. And water can be fed from this point if it is less, if required to feed manually. This is the water is being surrounded everywhere from here to here, from here to here, and this is the position of the steam which is required for our purpose. Here it should be exhausted from gas chimney itself. And the main stop valve is the here, which controls the maximum temperature pressure of the boiler itself. An oil tank is kept here itself and goes to the oil pump which pumps the oil through the filter to the initially heated electricity by electrolyzer, and coming out of the fume of the oil. Heated oil goes through here after opening the circle, and through number it goes through the corrugated flue gas itself. And it is being sometimes it is electricity supplied by electricity, also it is being sometimes supplied by steam to preheat the oil itself. Next, there is a damper which there is any oil flow here, it can be collected here, or any other impurities can be collected here and goes out with the front fan itself. Then tubes of flue gases are going out like this and going inside, and flue gases are burned, oils are burned here and goes through the flue gas itself and goes out through the outlet itself. Okay, this is the part up to which oil did the oil fired furnace in detail. I'll go into approximating. So I am doing stop here. Thanks for your coming, Shweta, and if anybody else is present out there.